Our speaker has joined us. So, good morning, sir. Am I audible to you, sir?
Yes. You're
Thank
audible, madam. Good morning, madam. Good
Good
morning,
morning.
everyone.
Sir, kindly let me introduce you formally first, then we'll start, sir. Thank you.
Sure.
So, dear participants, it is my honor to present amongst you Dr. Ranjit Ranjan Jha. He is an assistant professor in the Department of Computer Science and Engineering at the Institute of Technology, Patna, where his work spans medical imaging, analysis, deep learning, computer vision, and biometrics. His scholarship has attracted 400 plus citations, reflecting the impact of his contributions to diffusion and functional MRI and related AI methods. Today, he joins us to speak on from deep learning to generative AI, real world applications, drawing on both rigorous research and practical experience. Please join me to giving him a warm welcome. We welcome you, sir. Thank you for joining us today.
Thank you, madam. Thank you for such a nice introduction. So let me just share the screen and then I will start. The talk.
Yes, sir, you can share your screen now.
Okay. Hope my screen is visible to everyone. Can you see okay?
Yes, sir. Now it is visible.
Okay, great. Okay, so I just want to correct one thing. So my department is here mathematics. Like here we have mathematics and computing. So it's like mixture of computer science and mathematics.
Okay, sir. Sure. Will
Yeah,
do. Thank
but my background is computer science only. But I have been considered here for teaching the computer science subjects in the mathematics and computing course.
Okay,
Okay.
sir. Okay, sure. Thank
Okay.
you. Over to you, sir.
Yeah. So thank you everyone for joining this. So today, I'll be exploring this deep learning and how it evolved and then how it went to the generative AI. Nowadays, like we generally see that. Okay, so let's begin and start with the like from where it started. So actually, see if you just see it started from the artificial intelligence. Okay, so artificial intelligence is like one big area, and it it started to evolve like 1960s or 1970s. So actually, at that time when that time also like when we started to use computer system, then what initially like what we used to do like we generally like make the algorithms to solve some problems. And then what we do, we generally write the algorithms and then give into the computer system, and then your computer will solve that problem. Okay, but there, like we just see, the intelligence was from our side because we were writing the algorithm. We were planning like how to execute, how your computer will execute it. So like all the steps were given by us. Then later, like when then people realize like why not we should give everything or all this responsibility to the computer system. And then that area came that is called artificial intelligence. Now what it says that uh, we should give all the responsibility to the computer. So computer itself decide like which algorithm I should develop or I should write for solving the particular type of problem statement. Okay. So this is like intelligence we are trying to get from the computer system. And that's why this is called artificial intelligence. So we have human intelligence that we generally that like human do, and then we have artificial intelligence that machine does. Okay. So this is very big area, and inside this artificial intelligence, we have computer vision, we have machine learning, a lot of different subsets are there. Okay. So now let us see the computer vision. Now, computer vision, the task of the computer vision is just like similar to the human vision. So, like human vision, how we see the image, how we interpret the image. So, actually, if you just see, we have eyes and we take the images through the eyes, and then we have the brain that will interpret the image, like what is there inside the image or what is there inside the object. Can't we do the similar type of things using computer? And for that, computer vision came into the picture. So computer vision says that computer vision is having cameras like eyes. So here, like eyes are like cameras. So it will take the images from the cameras, and then it is having a set of algorithms that will solve some particular problems. Okay. So that is about computer vision. So it's like just mimicking the human vision. And then we have machine learning. So machine learning is a very hot area. So what machine learning does? The goal of the machine learning is to train the machine in a proper manner. So machine learning is having a set of algorithms which will help the machine to learn, just like humans. So we also learn from the childhood. So we just from the childhood we have been seeing a lot of things around us, and then we are just observing, and then we are learning from that. We are also making mistake. Again, from the mistake we are learning. That means like we should not make the same mistake next time. The similar thing machine learning also does. And it does this thing from the experience. Now we'll again talk about the experience. What is the experience? What is the meaning of experience? So that will come later. Now, if you just see here, there is overlapping between computer vision and machine learning. That means a set of algorithms from the machine learning can be used for solving some of the computer vision problems. Now, inside the machine learning, we have deep learning. And that is the, we can say, the widely used area nowadays. So everyone wants to use deep learning. So if you just see here, this deep learning is not is the separate. It's like part of the machine learning only. Now, what is the difference? What is the different thing there in the deep learning? So that we'll see. So actually, previously people used to use machine learning. Now those machine learning techniques are called as a traditional machine learning. And whatever we are seeing nowadays, these are called deep learning, and also we can say like as a new machine learning technique. Okay. So now we are going to differentiate between traditional machine learning and the new machine learning. And that new machine learning is your deep learning. So let's understand this thing through a picture. So that will give the clear understanding. So suppose you have given this image, and this is the image of car, and your goal is to label this image. Now, for the human, it's very easy. If this question is being asked for us, then we can easily say like, this is car. Why we are saying this is car? Because our brain is already has been trained. And now our brain is capable of giving the answer of the visual picture. Now, this job is not easy for the computer because computer is the first thing is like computer is having different language. Computer can only understand numerical values or binary values. So if you directly give this thing to computer, again, computer will not accept it. So what we need to do? We generally convert this thing into some numerical values, and then those numerical values would be given to the computer system so that your computer system will understand it. It's just like suppose you want to communicate with Chinese people, then if you speak in Hindi or English, they will not understand. So what you need to do? Either you learn the Chinese, that's very difficult, or you can hire one translator who will translate your language into the required language. And again, whatever you will be getting response from their side, that will be again converted to the your language. Okay. So again, here also we'll do the similar thing. So we cannot learn the computer language that is 00000010001. That is not possible. It's not possible to learn that. Then what we do, we generally take the translator, or we can say compiler, and that will help us to translate the things into the required language which is acceptable for the computer system. So that is again, that part is called image processing, and that will take care of this. So it will convert image into values, and then values will be given to the computer system. Now let's see. Once we converted it into the values, now if I just see the machine learning, that means traditional machine learning. What traditional machine learning does, it is having two guys, or you can say two algorithms. One guy is sitting here, and one guy is sitting here. Now this guy will take the important information from this, because this image is having a lot of information. It is having a lot of, we can say, a lot of not required information. So we are not interested in every information of this image. So the first guy or first algorithm, the job of the first algorithm is to get the, or to extract the required or important information from here. And then the second guy who is sitting here, which is called classifier, or that will give you label. Now this guy will take the important features from here, and it will give you the class, like this is car or not a car. So this was the machine learning. Now let us come to the deep learning. Or before reaching to the deep learning, first I'll just give you the problem with the machine learning. So if you go with this, everything is good. But the problem is that if this guy make mistake, suppose this first guy is making mistake, now you'll be getting wrong information. And if this guy gets wrong information, then finally it will give you wrong class. Now there is no feedback system. This guy cannot say to this guy like you are making mistake. That feedback system is not there in the case of traditional machine learning. And this was the problem, because there's no connection between this. They are two different guys. I cannot give feedback to this. So then machine deep learning comes and it says like, why don't we consider these all the things in a single box? And what it has done, it has just combined these two into single box. Now everything is happening in the single box. So suppose this will go out, like when you give this image and this will process, finally it will reach here. And suppose it has given wrong result. Now there is feedback system, and that will go back. And then it will say to everyone, please correct yourself. You are making wrong. So feature extractor will also correct itself. At the same time, your classifier will also correct itself. So everyone is correcting itself based on the feedback that it has got from the last, or from the output. Okay. So that's why this deep learning is highly popular, because you everything is in a single box, and it's the learning way is better than the machine learning, traditional machine learning. Okay. Maybe I can give you one real life example. Suppose I want to select one person for my research team. Then what I'll do, I'll take the interview of every person, and then I'll ask some questions, and then based on the answers, I'll be taking the decision. Now the thing is, how many questions or how much information I can get from the every person? The answer would be every person is having infinite information, because every person is having a lot of attributes involved with him, like his color, hair color, shirt, t-shirt color, everything, like his 10th marks, 12 marks, all those informations are involved with the particular person. But are we interested in every information for selecting that person for my research team? No, because hair color and all those information are not relevant for me. What should I do with those information? I'll be only focusing on the information which is required for selecting that person for my research team. So feature extractor will do the same. So it will extract only those information which are required for solving this problem. And then I'm sitting there. I'll whatever answer I'm getting from the particular person, then I'll see like whether that answer is suitable for my research team or not. If I find that person suitable for my research team, then I'll be selecting that person in my research team. So what is the decision there? Decision is yes or no. So whether I'm going to select that person or I'm not going to select that person. So this is also like two class classification problem. Either yes, either no. Okay. So here, like in machine learning, we have feature extractor that will extract the features, and then it will give to the classifier. That is again second algorithm, which will do the classification. In deep learning, everything is there in a single box. Okay. Now, what I said that I have every sample, every person from which I'm going to ask the question. Now, this every person can be considered as a sample. So in this case, every person is your image. So you have a lot of samples, a lot of images, and your feature extractor, or maybe in this case, are going to ask the question or going to extract the important information from the image. And then finally, it is having the classifier which will give the classification. And then again, feedback will go back. Now let us change the problem statement. Suppose instead of selecting person for my research team, now I'm going to select the person for my cricket team. Whether I can ask the same set of questions which have been asked for selecting that person for my research team. No, because if I'm going to select the person for the cricket team, question would be changed. So instead of asking 10th marks, 12, those are not relevant here. In this case, the relevant information would be like whether you have played Ranji or not, what is your like whether you are doing batting, bowling. So all those information which are related to the cricket would be asked. So you can realize here that whenever we are going to change the problem, your asking questions or questions would be changed. Okay. So again, these all the layers will take care of that. So it will learn only relevant questions which are useful for solving the particular problem statement. Sorry. So actually, this deep learning, if you just see, deep learning was already there in past also, at 1980s or 1990s. That time also people used to use this deep learning techniques. But the problem was that time we had few problems, and those problems were like computation and the data. So we did not have a good computation like GPU at that time, and also we did not have a good amount of data, and that's why like people did not take interest in this domain at that stage. Only few of people they just took interest. Otherwise, most of the people did not take interest at that time. But when 97, this 20, 2007, 8, 9 came, around that time, this computation power uh, become increased. And at the same time, one data set has been released that was ImageNet data set. And it was having millions, trillions of images. And it is having 1,000 classes. Now people got this thing. These were the hurdles. Now they got this stuff. Now everyone started to dive in deep learning, and everyone started to develop new algorithms. Okay. Okay. So it's like you can say like the starting point could be from 2008 or 9, and it was there before, but that is the actual starting point of this. Okay, so just see the basic problem, what we generally solve like in computer vision. So our goal is like this, just take the image and give the label. What I said that this is not the easy task because for us it's very easy, but for the computer system, it has to understand this. Your computer should computer cannot understand this visual picture, so you have to convert it into numerical values so that computer can understand it. Once you have converted into numerical values, then what you will do? Your goal is to get this type of boundary. So it is like suppose you have two classes, cat and dog. Then your goal should be to get one boundary here, which can differentiate between cat and dog. So all the images of cat should go this side. All the images of dog should go this side, and you should get this type of boundary, which can easily differentiate between dog and cat. It's just like we are drawing this India-Pakistan border. So all the Pakistani people will go this side, all the Indian people will go this side. So there should not be mixing. So if there's mixing is happening, then there is problem with this boundary. So we want such type of boundary which can differentiate between different classes. Okay, that's the goal. Okay, and this is also called linear classifier because it is linear boundary and it differentiating the two classes or more than two classes. But in reality, linear classifier will not solve all type of problems. Why? Because most of the problems are having non-linear nature. So they are very complex problems. So just using linear classifier will not solve that problem. Okay, and that's why this deep learning came into picture because this linear classifier was there before also, but deep learning is the new term which came here for solving all those type of problems which are very complex. Okay, so the starting point of the deep learning is neural network, and a neural network it is just having we can say like we have some input, some hidden layers, and then we have output. So you'll provide the input, and then input will be given to the this layer. These all the layers are there. These are like just different functions or deep learning layers, or we can say different deep learning functions. Those are being applied here, and finally you are getting this. Okay, so this is the final decision, like classes. So you'll give this image, this should give cat as a class. That is the goal. Okay, so let's see like what are the different problems that we generally like we are generally interested in. So one problem that we already have seen, that is the classification problem. So given the image, give the class. It's a very simple problem. It's like just we have to provide one label at the end. Now we have even more number of problems. We are not only having classification problems. So in reality, we could be having a lot of problems. Now this is another problem that is called semantic segmentation. Now this is, we can say, even more complex than classification problem. So we have given this image and it has to cluster every value here. These value are also called, this value is also called pixel. So every pixel value here in one of the classes. So in this image, we have different type of information. Suppose this is sky. These are trees. These are grasses. This is cat. So your model should cluster every class accordingly. So if you just see here, these all the values have been clustered as a sky class. This all the values have been clustered as a tree class. So in that way, like every pixel is getting classified in one of the classes. So this is a more challenging problem compared to this. Now let's see the another problem that is called object detection problem. Object detection problem is something where we have to localize the object, like what is the position of the object. Along with that, we also need to give the class of the object. So if you just carefully see here, so what it's doing, it's giving the location of this object, this we can say box, and along with that box, this also giving the color, and then that color is representing the class. So if this is red color, this is dog. This is again green color, that is dog. This blue color, that is again cat. So in object detection, the goal is to localize the or to give the location of the object along with class of the object. Let us see the real life application of it. So you might have heard this name driverless car. So how driverless car is running on the road? So if you just uh, try to realize it, then these all the driverless car which are running on the road, they are also in some way using this object detection. So what are the things with car? So actually, if you just see, car is having a lot of sensors, a lot of cameras. So when it is running on the road, it will take images of like images, all the images which are coming around the car. Okay, like on the road or maybe on the both side or on the all side, not the both side, all the sides. And then it's taking the images, taking the picture of the object, and then it is having a set of algorithms which is deciding something from that image. So suppose if you have object detect, suppose it has to detect the object because on the road, suppose pedestrian is going, or maybe some stone is there, or maybe something is there. Now in the car there is no driver. It's like driverless car. So car itself has to decide like when it has to stop or when it has to just going without stopping somewhere. Okay. So everything is being decided by the car only. So when car is running, now, if it is taking images and what it feels that one pedestrian or one person is there on the road, and then it also finds like what is how far that person is from the car because it has to put the brake, otherwise it will hit the person. Okay, so for this purpose, it uses object detection because object detection will give the location along with the class. So class is also important. So suppose the class is stone, small stone. In that case, there is no need to stop there because that will not harm the car. But if the person is there, then if car does not stop, then it will hit the person. And that's wrong. So again, this object detection is very, very helpful. Now let's go one step ahead. So in the case of object detection, we are just approximating the rough estimation. So it's not touching the object. It's just like one bond, just a box we are predicting. But in some problems, we want exact position, and that is called instance segmentation. So if I go for instance segmentation, I'm interested in exact position, not rough position. Okay, so it will give you exact position. Now, what is the use of this? There are a lot of applications where this is being used. Let's take the example of medical system. Suppose doctor is doing surgery of the brain, and suppose some tumor is there inside the brain. Now, before doing the surgery, doctor needs to know like what is the location of the tumor and which type of tumor is. So again, if I go with object detection will give the location, but this is not giving the precise location. Suppose tumor is this, and this is giving this much information. Then what doctor will do? It will just they will just insert the needle, and this will just take it take this tumor out from that region. But during that, what will happen since it is not giving the exact location, then it your doctor will take these all the information from the brain, and these are like good area. Okay, so what is happening that if doctor take it this full information, what will happen? These are like good tissue, and if it is coming, good tissue is also coming from your brain. You know that your brain is controlling whole body, so every part is responsible for some part of the body. So if these parts are getting out from here, some control or some of your body part will be paralyzed. So you cannot go with rough estimation. You want exact location. Okay. Let me just give you one example, one story. Like one guy, he was like still he's alive. So he was like this guitarist. Okay. So he was like very popular in USA. So he got this tumor in his brain, and then he talked to doctor, and then doctor said that we'll will do the surgery of your brain and we'll take out the tumor from the brain, but we cannot give guarantee that after the surgery everything will be good. because whenever we are going to the brain, we are going to take some things from the brain, some other part will be also disturbed, because whether you are going precisely, then in that case also, because insert you have to insert something, so it will disturb the tissues in between, whichever which are the tissues coming in the in between, all those tissues will be disturbed. Now, if tissues are getting disturbed, then it will create issue for the body. So what doctor said that we'll do the surgery, but some of the parts or maybe some problems will happen after your surgery. Maybe you will be missing, you will be losing control of some of the part of your body. Then what that guy said that uh, I'm happy with that, but there's no issue because I know that there's no alternate option. So I have to accept that. But only the thing is that I'm I'm very good in this guitar, okay, playing guitar. So I should not miss this. I should not forget this art, because this is I can only survive with this. Okay. So then the author said, okay, it's fine. You want to we have like this art even after surgery, then what we'll do? We'll do something. And then what they have done when they were doing the surgery of that person, then at that time that person was just playing the guitar, and doctor was just observing, so that there should not be problem there. Okay, so if they feel that he's getting stuck somewhere while playing guitar while doing the surgery, then they will stop. So, sir, finally, the surgery happened successfully, and then he got he lose some control, but again, this art was like it was there with him, and still like he's very good in that art. So that's why what I'm saying, that whenever you are going for brain surgery, like there is it will create some issues, but again you have to put the priority, like what part you want to be survive, or what you want to keep it even after surgery. Okay, so that's why doctor asked before doing surgery, like what are the priority based things that you wanted to keep even after the surgery. So you can see like what this deep learning or this instance segmentation can help in that case. Okay, then there are a lot of other applications, like even beyond image, you can go for the video. So this is the video, like even the video, can we classify it? Nowadays, people we generally use a lot of videos, generally see a lot of videos, or maybe on this reels, short. So that's why we are interested in videos. So why not we should apply some deep learning algorithm on videos? Okay. So this one problem is called video classification, just giving the video. What is the class of the video? Like what is happening in the video? So whether that person is, you can say like running, jumping. So these are the different classes. Then again, even we can go for the more challenging problem. And that is like multimodal video understanding. So like here in this case, video is just like one sequence of images. Okay. Now in this case, we have a sequence of images along with the sound, because that sorry, that person is also playing the guitar, playing something, not guitar but something. So that sound is coming, so sound is also coming, and at the same time he's also doing some activity. So these two things are involved there, one is like activity and one is sound. Now this is called multimodal, because one is we have two type of information. Now can we understand, or can deep learning understand this scenario? And again, we have a lot of algorithms which can understand this, and it can give you like what is happening in this video. Now, again, this is one area where people just try to interpret. So you generally consider this deep learning as a black box, because we don't know what is happening there. But nowadays, people just dive into that domain, and then they are just trying to even understand like what is happening inside that, and that is the area so in which like people are doing some research, like some mathematician or maybe mixed people, they are just jumping in this area, and then they are trying to interpret like what is happening in every layer of the neural network. Okay, so one is linear, one is like a neural network that we started with. Then we have multi-layer, then we have convolutional neural network. So neural network, like initially that came, and that has solved a lot of problems. But there was some problem in the neural network, and that problem was that your neural network was just seeing the things from the top. It's just like you are going to the moon and looking the Earth, and then you are deciding like what is there in the on the Earth. So it's very difficult. Like if you go to the moon, you are just seeing the broad view of the Earth, top view of the Earth. So sometimes that is fine, but many times we want to see Earth in a great detail. Okay, and that's not possible from the moon. So then CNN came, and CNN says that I'll if I have to take the decision or I have to decide something about the Earth, then what I'll do, I'll go firstly, I'll go close to the Earth, I'll take the image, then I'll go far, again I'll take image, again I'll go far, again I'll take image, and finally I'll be reaching to the moon. So in this is called hierarchical way of learning. So firstly, I'll go very close, then far, then far, then far, then far, then far. So this is having that type of algorithms which will take care of this. So it will see the image from very close distance, and then slowly it will go far, and finally it will take the decision. Okay. So this is like CNN is better than the this neural network in many cases. Then we have one another set of family that is for text. So this started with recurrent neural network. So again, you might have heard this. Maybe you might be aware of this natural language processing. So we generally deal with text. So for that type of things, we have a different set of networks. So like recurrent neural network, it was initially it was very popular, and then there was some issues in the recurrent neural network. Then people shifted to the transformer, which is like we can say the benchmark architecture nowadays. So everyone who use transformer. Transformer has given a lot of advantages over this recurrent neural network. And surprisingly, this transformer nowadays, like it initially it was being used for NLP tasks, but nowadays for every type of task, people use transformer. So even in the computer vision, medical imaging, all type of tasks, for solving all type of tasks, we use transformer. Okay, now another apart from this classification, segmentation, what we have seen before, we can also solve some other type of problem. And this is one type of problem that is called generative modeling. So can we generate something? Now this is the example. So you can see like this is being generated by the model, by deep learning model. So you just give this image. This is the natural image, and your model is giving you the cartoon image in a second. Now you can see like how good this model is doing. The thing is, if you give this thing to the cartoonist, he or she may take six hours, 5 hours, maybe one day to do this. Now the same thing you are getting from the model in a second. Now in this way, it's taking the job of the artist. Okay. So what this deep learning or what this new technology is saying that if you want to if you want to survive, you should be updated. Otherwise, it's very difficult to survive. Okay. So again, another type of interesting problem. So here in the previous case, I've just shown that we have given one image and you are just generating another image. Now this is the case where we are just giving the text. So you just give text to the model and your model will give you the image, generated image. So we have already available tool that is Delhi E2. We can find it out from the internet, and that tool accept this text and it will give you the image. So what I'm saying, like teddy bears working on a new AI research underwater with 1980 technology, and you can see like similar type of image you are getting here. So like it's underwater, two teddy bears are there, and then technology is like looking like a 1990 technology. Even few more interesting examples. So teddy bears working on new AI research on the moon in the 1980s, and you can see like the same type of image you are getting here. Then rabbits attending a college seminar on human anatomy. You can see like all the rabbits are here sitting there. one is like teacher, he's also there, and this is looking like a human anatomy, and he's like teaching that. Or wise cat meditating in the Himalayas searching for the enlightenment. So these are like hypothetical images that we have asked from the model. So in this way, you can write any text to the model, and your model will give you some image for that text. It's just like when I'm going to the class and I'm asking everyone to write some to draw something on the page. So in the similar manner, you can also ask from the model. So model can just give some text, and model will give you the image for that. Now, you might have heard this, like everyone must have used this Chat GPT. This Chat GPT is again one variant of the transformer. So that is GPT. So that is again coming from the transformer. And in the Chat GPT, you know that it takes the text and it will give you the text. So you are asking something and you will get the response from the Chat GPT. Now we have GPT-4, which is just one step ahead. So in the case of GPT-4, you can give the text along with the image. So like this, you're giving the image and then you're asking the things from the image. What is unusual about this image? And then your GPT-4 is giving you the answer. The unusual thing about this image is that the man is ironing clothes on the ironing board. So in this way, like now you can see like how this area, how fast this area is evolving. Okay. So, okay. So, there are a lot of applications where this deep learning is being used. So in this short time, it's not, I cannot cover each and every application. So again, this is, we can say emerging area. And if you are interested, you can just jump into that area, just learn some new techniques like transformer based techniques. And then you start working on some problem statement. Okay, but we should also recall the people who have given this deep learning to us. And these are the people, Jeffrey Hinton, Bengio, Deacon. These are the people who have, they are also called godfather of this deep learning. And they have given a lot of algorithms for solving a lot of problems in deep learning. And for that, they got Turing Award, which is like Nobel Prize of the Computer Science in 2018. Now, Jeffrey Hinton, he also got Nobel Prize in Physics in 2024, along with this guy. So these two guys got Nobel Prize in Physics. So this he was from the physics background, and he's from the AI background. Now you can see like in every area people started to use this. So why this guy got this award? Because a lot of algorithms developed by him has been used have been used in physics for solving a lot of unsolved problems. Even in the same year, in the chemistry, three guys got the Nobel Prize, and two of them are from the AI background. And what they have done, they have just solved some chemistry-based unsolved problem using deep learning methods. So you can see, like, if you want to survive in any area, in some way you have to use deep learning. Okay, so this is the last slide. So I'll not take much time. So this is the last slide. So nowadays, like people also have done some experiment on chat GPT user and non-chat GPT user. So what they have done, they have just taken the MRI scan of uh, different chat GPT user and MRI scan of different non-chat GPT user, and then just they have just done the average study. And what they observed that whoever is using chat GPT, they are having this type of structure. It means a lot of neurons are not getting activated because they are not using their mind. They are just totally relying on the chat GPT. And whoever are not using the chat GPT, they are having this type of structure. That means a lot of neurons are getting activated. Okay. So the point is, you should not use ChatGPT blindly. If you do that, you'll be relying on this side. You can use ChatGPT because that is the new technology. But thing is that we should also use our mind. We should not be dull, okay? Because if you are just using ChatGPT blindly, that means your computer is getting intelligent, but at the same time you are getting dull. So we should not be doing that type of things. You use ChatGPT, but whatever response you are getting, you analyze it, you use your brain, you you read those all the things, and then you take your decision, not ChatGPT decision. So with that, I'll stop here. Thank you.
Thank you, sir. That was very rightly said by you that ChatGPT use should be ethical. There are a lot of things that the critical thinking and everything is not pursuing with the upcoming generation, because everything is only reliable on these models that we can enter the text, we can get the results, and all will be fine. We are not thinking, we are not, aware of the ethical use of that. We can get ideas, but we shouldn't rely on this only. It's a very right point that you have highlighted.
Thank you. Thank you.
Thank you, sir. So thank you so much, sir, for this very informative and very interesting session by you. We are very heartily thankful for you for this. Thank you so much, uh, dear participants. Now I have an announcement that the participant who having a paper presentation in track FD5 and FD6, those can join the breakout rooms now, and rest of the people may leave the
SD11, SD2.
something you want to highlight, sir, Abhishek, sir?
Ma'am, second day,
I can leave the meeting. Is it fine?
SD1 and
Yes, sir. Yes,
Yeah,
sir.
thank you. Thank you.
Thank you.
Thank you.
Thank you, sir.
other can leave the meeting, ma'am.
Okay, yes. Others can leave the meeting. Those who have paper presentations in FD5 and FD6 can join the
SD1,
breakout room.
SD1 and SD2.
Oh, sorry. SD1 and SD2. Thank you.
I'm starting the breakout room.